welcome to Statistronics. I am Dr. Twane. In today's econometric class, our topic is matrix regression. And so at the end of the class, you will have a good understanding of the basics of matrix regression, the principles behind matrix regression, and you'll be able to apply the matrix regression. So often, when we say regression analysis, what comes to mind is looking at the effect of one or more variables on the other. And so, if we are looking at the effect of, say, one variable on the other, we'll have, say, y is equal to beta 0 plus beta 1 x1 plus, let's say, u, where y is our dependent variable, VO is our intercept, B1 is our slope, or we call it regression coefficient, and X1 is the independent variable, where this is the stochastic term. It is also possible to have the effect of two variables on one, and so we'll have y is equal to, say, beta 0 plus beta 1 x1 plus beta 2 x2 plus u. The only difference here is that we have an additional parameter, an additional explanatory variable. This remains the independent variable, and this is the error term. We can extend it to 3, where we have y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus u. So here we have 3 explanatory variables, x1, x2, and x3. Then we have 4 parameters to estimate, 3 regression coefficients, x, beta 1, beta 2, beta 3, and an intercept. This is a dependent variable. So when we have k number of explanatory variables, then we can say the general form is y is equal to, say, beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus, and it will continue to plus beta k xk. So that's the general form of a multiple regression with a given number of explanatory variables. Now the thing is, this can be written more compactly. And I'm sure sometimes you have seen where you have y is equal to x beta plus u. Now, this is the same as what we have here, where x represents the number of explanatory variables from x1, x2, up to xk. And then this is the error term, right? And while this is a dependent variable. Now, if you look at this as a matrix, yes, this will be n by 1 vector. This is n by k matrix. This is k by 1 vector or column vector, and this is n by 1 column vector. So we can write this explicitly as this y is equal to, say, y1, y2, y3, and it will continue up to yn. So that if we want to, normally when you name a matrix, we go row by columns. So how many rows do we have here? 1, 2, 3, up to n. So it will be n by how many columns? 1. That's the principle behind our matrix nomenclature. So the next one is x. So our x here will be equal to, we'll have 1, 1, 1, and it will continue up to 1. So x will be x11, x12, x13, and that will continue up to x1n. Now the second variable will be x21, x22, x23, and it will continue up to x2n. Now the third explanatory variable will be x31, x32, 3, 2, x, 3, 3, and that will continue up to x, 3n. And so it will continue to the number of explanatory variable, which is k. I will put that as x, k1. This will continue to x, k2. This will continue to x, k3, and up to x, kn. So if we want to look at the dimension of this matrix, you see that this is by the rule 1, 2, 3, and it continues up to n. So this is going to be n by how many columns do we have? 1, 2, 3, 4, and it continues up to k. So it's n by k. Also, our beta, let's know that this is our beta hat, we have an estimate. So our beta hat will be equal to, say, beta hat 0, beta hat 1, beta hat 2, and it will continue up to beta hat k. So that this matrix also is equal to 1, 2, 3, 4, up to k. So it's k by how many columns? 1. So this is k by 1 matrix. While our u, the error term, is equal to, say, u hat 1, u hat 2, u hat 3, and it will continue up to u hat n. So again, the dimension of this is going to be 1, 2, 3, up to n. So it will be n by 1 matrix. So what we have here as a general form of a multiple regression has been presented in matrix form in this nature. But do not forget that our emphasis is that our y is equal to x beta hat plus u hat. Okay, now please do not forget to look at our previous video before this. In that video, we were able to derive the estimator of this beta, where we showed you that our beta hat is equal to x transpose x inverse x transpose y. We also told you that sometimes this is also presented as, say, x prime x inverse x prime y. Okay, now when we have this, in the case of a simple regression where we have one dependent and one independent variable, like what we have here, now we can still use this to estimate that simple regression, much like we can also use this to estimate a multiple regression. So let's start from the simple. So where we have a simple, I'll put it as simple model. Now, in the case of a simple model, let's start with this. Our x transpose x will be equal to, now, what is x? For two variables will mean that we have just this and this as our x. So the x transpose is going to be the transpose of this. And you know that in matrix transposition, what we do is we exchange the row for column or column for row. So this first column is going to be the first row, and the second column will be the second row, such that x transpose will be 1, 1, 1 up to 1. That's the first column being the first row. Now the second column, x11, x12, x13 up to x1n. So the second column, now second row, is our x transpose. So what's x itself? X itself is 1, 1, 1 up to 1. And then we have x11, x12, x13 up to x1n. Okay. So in matrix multiplication, what we'll do is to multiply the row by the column. And so what in this case we are going to have 1 times 1, which will be 1, plus 1 times 1 will be another 1, plus 1 times this one will be 1, plus, and it continue to 1 times 1, which will be plus 1. If you add this n times, because we are doing this n times, then it is going to be equal to n. Okay, now The next thing we are going to do is to multiply the first row by the second column. And we'll have 1 times x11, which will give us x11. 1 times x12 will be x12, plus 1 times x13 will be x13, plus, and it continue to plus 1 times x1n will be x1n. So if we sum this, at the end of the day, we'll be summing summation of x1. Okay, so now the second one, we're going to multiply the second rule by the first column. So we have x11 times 1, which will give us this. x12 times 1, which will give us this. x13 times 1, which will give us this. And we continue to x1n times 1, which will also give us this. So at the end of the day, we are also summing what? x1. Now, the next one will be multiplying this second rule by the second column. So we have x11 times x11, which will give us x11 square. x12 times x12 will give us x12 square. x13 times x13 will give us x13 square. And it will continue to x1n times x1n, which will also be x1n square. So it will be x11 square plus x12 square plus x13. And at the end of the day, what are we doing? Summing x1 square. Okay? So this is the result of x transpose x. Okay. Now, the next thing is we have obtained this, remaining this. So for this, we'll say that our x transpose y is equal to, we already have this as our x transpose. So we have 1, 1, 1 up to 1, x11, x12, x13 up to x1n. So that's our x transpose. So our y from what we have initially here is y1, y2, y3, and it will continue to yn. So if we multiply that, it will be 1 times y1, which will give us a y1, plus 1 times y2 will be y2, plus 1 times y3 will be y3, plus, and it continue to plus 1 times yn will be yn. So at the end of the day, we are summing y. Okay? Now, the next will be x11 times y1. We'll have x11 y1 plus x12 times y2 will be x12 y2 plus x13 times y3 will be x13 y3 plus it continue to plus x1n times yn will be x1n yn. So if you watch this, you see that what we are summing is x1y. So this will be summation of x1y. Okay. Now, substituting, you now see that what we are given initially from what we have here is that our beta hat. So you see that our beta hat for two variables, a simple model, beta hat is equal to, we have beta 0 and beta 1, which is equal to, now the next thing is x transpose x, which we obtain as n summation of x1, summation of x1, and summation of x1 squared. But note that there is an inverse here. So we'll put the inverse and then our x transpose y. We have obtained the x transpose y as this. So which will be summation of y and summation of x1 y. So we can use this to calculate beta 0 and beta 1. Once we have this matrix, take the inverse and multiply by this vector of constant. And you have the values of your beta 0 and beta 1. There's one interesting thing that can also come from here that you hardly see. And what is that? Now, if you look at our previous video, when we derive this beta hat as x transpose x inverse x transpose y, before we got here, we said that our beta hat, let me do this. We said that our beta hat is equal to, when you say inverse, inverse will mean 1 over that value, which is x transpose x. And then we have x transpose y. So by this, it means we can multiply this by this. And if we do that, we'll have x transpose x beta. Beta hat is equal to x transpose y. Okay, now having done that, you look at it again. This is what we obtain as x transpose x. So if we write that as n summation x1, summation x1, and summation x1 square, that's our x transpose x. Then our beta hat, we have it as beta hat 0 and beta hat 1. And that will be equal to x transpose y, which is this was obtained as summation of y and summation of x1y. So this will be equal to summation of y and summation of x1y. Okay? I'm sure this will be very familiar. And this is what we call the normal equation for two variables. Okay, it is also possible that we will have a multiple model that is not just a simple model. In that situation, we can still use our beta hat is equal to x transpose x inverse x transpose y. Okay, so what then will be our x transpose x? So x transpose x will be equal to, remember that for x transpose, we will have 1, 1, 1, and then you continue to 1. So that we'll have x1, 1, x1, 2, x1, 3, and you continue to x1n. But because we are considering 3 variables, here will be up to 3. So we'll have another one, x21, x22, x23, up to x2n. So this become our x transpose, and x itself will be 1, 1, 1, and you continue to 1, x1, 1, x1, 2, x1, 3, and up to x1n. So we'll have another one, which is this other one, x21, x22, x23, up to x2n. Now, we multiply these metrics just like we did in the other case. So we'll have 1 times 1 will be 1, plus 1 times 1 will be 1, plus 1 times 1 will be 1, and it will continue to plus 1 times 1 will be 1. So if you add all of this, you see that it will be 1 plus 1 plus 1 n times, which is going to give you what? N. So we multiply 1 by all of this, just like what we did earlier. 1 time this will remain this, 1 time this will remain this, 1 time this will be this, 1 time this will be this. And so when we sum this, we are now summing x1. The same thing is applicable here. 1 time this will be this, 1 time this will be this, 1 time this will be the same thing, and 1 time this will also be the same thing. So at the end of the day, we are summing this, which will be what? Summation of x2. Okay, we now use the second row. We multiply the second row by the first column, and it will be 1 times this, which is going to be this. 1 time this is going to be this. 1 time this is going to be this. And 1 time this is going to be this. So that what we'll be summing is this, and that's equal to what? Summation of x1. So by the time we multiply this by this by this, is this time this is square. This time this is the square of this. This time this is the square of this. and this time this is square of this. So that we will have summation of x1 square. And then x1 1 times x21 will be x11 x21. x12 times x22 will be x12 x22 plus x13 times x23 will be x13 x23. So it will continue like that to x1n times x2n, which is x1n x2n. So at the end of the day, we are summing, we'll have summation of x1 x2. Now, the next thing is to multiply this by the first column. 1 times all of this will remain the same thing. So, which ultimately will give us the summation of this. So, we'll have summation of x2. Now, the second one will be x22 times, I hope you're saying that there's a space in between here, so you don't get it wrongly. Okay. All right. So now multiplying this by this will be exactly getting this, because we have x21 times x11, which will give us this. Multiplying this by this will give us this. Multiplying this by this will give us this. So at the end of the day, we're also having the sum of that, which is summation of x1 x2. And then the last one will be now x21 times x21 will be x21 square, plus x22 times x22 will be x22 square, plus x23 times x23 will be x23 square, and then x2n times x2n will be x2n square. So we're summing x2 square, so which will be equal to summation of x2 square. So this is the result of the x transpose x. Okay, if we have this for x transpose x, how about x transpose y? Okay, we'll say that our x transpose y will be equal to, now this is our x transpose, 1, 1, 1 up to 1. Okay, and then we'll have x11, x12, x13 up to x1n, x21, x22, x23 up to x2n. So we're multiplying that by y, and our y is y1, y2, y3 up to yn. So when we do that, we will have 1 times y1 plus 1 times y2 plus 1 times y3 plus 1 times yn. So we are summing y, and that will be equal to summation of y. Okay? So that we are multiplying this again by y1, which will be x1, 1y1. This time this will be x11, y2. This time this will be x11, y3. And this time this will be x1n, yn. So that we are summing summation of what? x1, y. And then the next one will be x21 times y1, which will be x21, y1. x22 times y2 will be x22, y2. x23 times y3 will be x23, y3. And then x2n times yn will be x2n, yn. So to sum that result will give us summation of x to y. So that becomes our x transpose y. So if we have this as our x transpose y, then remember that our beta hat is equal to, in this case of 3 variables, will be beta hat 0, beta hat 1, and beta hat 2. And that is equal to, okay, you note that we are saying x transpose x. What is our x transpose x? These are x transpose f. So the whole of that will be equal to, we'll have n summation of x1, summation of x2, summation of x1, summation of x1 square, summation of x1, x2, summation of x2, summation of x1, x2, and summation of x2 square. So it will be the whole of that. But note that it has an inverse. So we put the inverse here, inverse, and then our x transpose y, which we obtain as this. So the whole of that into is into summation of y, summation of x1 y, and summation of x2 y. So if you get the inverse of this and multiply by this, it will give you beta 0, beta 1, and beta 2. Okay, now, having done that, just like what we did here, what we showed here, now you believe with me that like we showed earlier, you see that in this case, our beta hat, which is given as x transpose x inverse is x transpose y. This can also be written as beta hat is equal to, when you say inverse is 1 over that value, which is x transpose x, and then you're multiplying the whole of that by x transpose y. What you have here is the same with what you have here. And for that reason, you can multiply this by this. If you do so, you will have x transpose x beta hat is equal to, this has gone this way, so you're only left with what? X transpose y. And so remember again that this is this, which is n summation of x1, summation of x2, summation of x1, summation of x1 square, summation of x1, x2, summation of x2, summation of x1, x2, and then summation of x2 square. So this beta, this is what we have written here now. Now this beta will be beta hat 0, beta hat 1, and beta hat 2. And then that is equal to our x transpose y is what we obtain here, which is summation of y, summation of x1 y, and summation of x2 y. Okay, so this is also what we call the normal equation for 3 variables. If you have these values, you'll be able to calculate all these parameters from this normal equation. I hope you enjoyed it. If you have any question, feel free to go to the comment section. Let us know what you feel. If there's a particular problem you want us to solve, feel free to let us know. But please do well to like our video, do well to subscribe to our channel, and we are here for you. Thank you, and God bless you.